For billions of years, our solar system has been riddled with peculiar objects of rock and ice. Though humans have long speculated their meaning, it has been only in the last few centuries that we have truly been able to understand these mysterious bodies. Come along and discover the secrets of space debris. First on our journey are comets. Sometimes called space's snowballs, these visually astounding orbiters attribute their magnificent tails to their icy anatomy. Allow me to explain. If and when one nears the sun, the comet's ice will sublimate and turn directly into a vapor, leaving behind it a gaseous trail. Comets are able to be composed of ice because they come from regions far from the sun. We'll touch on these regions later on in the video. Comets even play a role in meteor showers by providing from its trail smaller debris and dust clouds. As the Earth progresses in its revolution around the Sun, it will run into these debris clouds and they will brilliantly burn up in Earth's atmosphere. Next are asteroids. This class of objects contains some of the larger bodies of space debris in the universe. Their rocky composition comes from a mix of various metallic elements such as iron, nickel, and cobalt, with some even having rarer elements like silicon in them. An asteroid's physical makeup is determined by what classification it is. There are 3 of these classifications, each corresponding to unique textures and materials. The first of which is called the C-type. The C-type asteroid is the most common kind of asteroid and is composed mainly of carbon compounds. In a telescope, these will appear darker than other asteroids. Next are S-type asteroids. The S-type asteroids are quite a bit brighter and less dull than their C counterparts. They appear much stonier in their composition and are rich in mineral content, making them a high priority amongst prospective asteroid miners. Last is the M-type asteroid. Simply put, the M-type asteroid is a mixture of both C and S types, so that its brightness is medium and composition is mixed. Asteroids differ from comets in that they lack the outer ice covering that gives comets their characteristic tail. This is because asteroids come from a warmer region in between Mars and Jupiter known as the asteroid belt. Also important to talk about are meteoroids, meteors, and meteorites. These 3 can be best understood by thinking of them in steps. First is the meteoroid, which is a rocky object in space, smaller than an asteroid, but bigger than a speck of dust. When the meteoroid enters Earth's atmosphere and begins to burn up, it becomes a meteor. It will remain a meteor until it touches down, at which point it becomes a meteorite. But in order to fully understand these unique objects, we must first take a look at their past. As you learned earlier, some 4.6 billion years ago, our solar system came into being. Disks of dust collided and formed the planets that we know today. But after the planets had finished coming together, there was still more material. This stray material collected mainly around the gas giant Jupiter due to its strong gravitational pull. Eventually, the material coalesced into a ring of planetesimals and rubble and became the asteroid belt. And now, a quick word about the dinosaurs. 65 million years ago, at the end of the Cretaceous period, a 6-mile-wide meteorite hit Earth just off of the Yucatan Peninsula in Mexico. This event would lead to a global energy crisis as no sunlight was able to penetrate the dark and cloudy sky. The dinosaurs died. On January 1st, 1801, the first asteroid was discovered by Italian monk Giuseppe Piazzi. Piazzi was looking for the missing planet between Mars and Jupiter that was proposed to exist according to the Titus-Bode rule. The Titus-Bode rule is a rough model that predicts the spacing of the planets. The rule states that there should be a planet approximately 3 astronomical units away from the Sun. In his search for this planet, Piazzi recorded the largest asteroid, Ceres. Ceres is the largest object in the asteroid belt and takes up approximately 1/3 of the belt's entire mass. Because of this, the asteroid itself is actually considered a dwarf planet. It will remain a dwarf planet until the 4 objectives of planethood according to the International Astronomical Union are met. It must A. go around the Sun, B. not be a moon, C. have a spherical shape, and D. must clear the neighborhood around its orbit. Until that last point is met, it will remain a dwarf planet. Side note, ever wonder why space debris is shaped so oddly? It's because these smaller bodies have less mass, and therefore less gravity, and without significant gravity, variations are allowed to be more pronounced, because there is no gravity to smooth them out.
Hey, John Williams here to talk to you about Comet Hyakutake, first discovered January 31st of 1996. Its name was C/1996b2. It was one of the closest passes to Earth in the past 200 years. It passed zero point 0.1 astronomical units away from Earth. The first X-ray emission ever received from a comet came off of Comet Hyakutake. Another thing about this comet is it had the longest tail ever known. We know this because the Ulysses spacecraft, when it was going through space, felt some turbulence, and they looked back to see what comet passed, and it was Comet Hyakutake, and that was over 500 kilometers back. Hey, back again. This time to talk about a different comet named Shoemaker-Levy 9. First broke apart in 1992, collided with Jupiter in 1994. When it broke apart, it broke into 21 different fragments. There's a lot of cool things to know about this comet. It was the first direct observation of solar objects colliding. One of the other things that's cool about it is it was the first observation of a comet orbiting a planet. Hey, here to talk about Ida and Dactyl. Ida is a big asteroid that's about 19 miles across. Dactyl is the counterpart to Ida. Dactyl is the moon of Ida. Dactyl is only 1 mile across. Ida is a very rocky, and full of craters asteroid. They're both S-class asteroids, which means they're very rocky. This proves that asteroids can have moons.
Hello everyone, today we're talking about the Kuiper Belt. Comets and asteroids have been around for more than 4.6 billion years. These objects have originated in only two regions in our solar system, one of which is called the Kuiper Belt. It is a disc-shaped region located near the planet Neptune. It extends to about 30 to 55 astronomical units and contains to about millions or trillions of comets. The dwarf planet Pluto may be the best known of the larger objects in the Kuiper Belt. Comets in the Kuiper Belt take less than 200 years to orbit the Sun and travel approximately in the plane in which most of the planets orbit the Sun. The first of these unusual bodies, which astronomers call Kuiper Belt objects, came to light in 1992 and were discovered by Dave Jewett and Jane Lowe, a pair of scientists who didn't believe the outer solar system was empty. Beginning in 1987, they were in search of dim objects beyond Neptune. It took 5 years, looking off and on through the University of Hawaii's 2.2-meter telescope, but they finally found what they were after, a reddish-colored speck 44 astronomical units from the Sun. The second region is called the Oort cloud. It is named after the famous astronomer Jan Oort. Just like the Kuiper Belt, it is an extended shell that exists in the outermost of the solar system containing icy objects. It is a spherical region which consists of long periods of comets that have been discovered. The cloud of particles are remains of disk materials from the formation of the Sun and planets. A theory states that the material now is in the Oort cloud probably formed from an epoch of solar system formation. As the planets grew, Jupiter in particular migrated to its current position in the solar system. Its gravitational force is thought to have ice objects which go out of their current position in the Oort cloud. The Near Shoemaker, also known as the Near-Earth Asteroid Rendezvous Shoemaker, was named after the planetary scientist Eugene Shoemaker. It was a robotic space probe designed by the Johns Hopkins University for NASA. It was designed to study the near-Earth asteroid from close orbit over a period of a year. The mission succeeded in closing in with the asteroid, orbiting it several times. It finally landed on the asteroid on February 2001. In 2015, NASA has approved for two robotic missions to visit asteroids in the early 2020s. There were about 28 proposals submitted in 2015, but only two were approved, called Lucy and Psyche. They will visit worlds far, far into the universe as scientists figure out the violent history of the solar system. Lucy will launch in October 2021. The probe's first destination will be on April 2025 on the asteroid Donald Johanson, named after the paleontologist who discovered the fossil Lucy, a human ancestor whose partial skeleton was discovered in Ethiopia in 1974. This Lucy spacecraft will then head as far as 500 million miles from the Sun on a series of high-speed passes through groups of Trojan asteroids. Lucy will also fly by at least 6 Trojan asteroids at close range from August 2027 through March 2033. The first time a spacecraft has visited a member of the Trojan population, which some scientists estimate may number in hundreds of thousands of objects.